Hi everyone. This video is meant to supplement your packet for the week of May 11th on composites of functions. I'm going to start on page 1 and we're going to review function notation first before we even talk about what it means to be a composite function. So as you can see here, we have two different functions. We have this table that represents f of x, and our second function, this table represents g of x. And just to review function notation first, if I ask you for f of 3, that is asking what is the output of the f function when you put 3 into the function. So remember, this 3 is your input. So when we come over here and look at the inputs, we look for 3 and we look over here to see that our output is 7. So that means f of 3 is equal to 7. Okay, and I can do the same thing for g of 3. Now g is the name of the function, so that tells me which table to look at. So g means I'm looking over here at this table. Again, 3 is my input, and in this case my output is 8. So you have to look for the input first and then figure out what the output is. And you could do f of anything. Okay, or g of anything, or depending on what the function is and what the domains are, and we'll get into all of that. So a composite function is when you put one function into the other, or if we read up here, when the output of one function is used as the input for a second function. The combined function is called a composite. So we're going to learn what that means now. So the first thing we're going to use x equals 1 as an input to the composite. So if we put the number 1 into a function, we're going to put it into the f function first, what is going to come out? So we're going to look at the table. Here's 1 going into the f function. 5 is coming out. So then what we want to do is we're going to now use this output, the 5, and that's going to be our input into the function g. So we look at our table. Here's 5 as an input for g, and what's going to come out of that is 6. So when I use 1 as an input for the first function, the output is 5. And when I use 5 for the input of the second function, the output is 6. Okay, so this picture can explain what's happening. We can also use function notation here and say that f of 1 is equal to 5 because we put 1 into the f function and got 5 as our answer. And g of 5, because we're putting 5 into the g function, equals 6. So that's function notation. And when we do composition notation, so composites, we want to think about the fact that we took this f of 1 output, that f of 1 value, and we put that into the g function. So we read this as g of f of 1. And so when we do g of f of 1, we work from the inside out. So this is equal to g of f of 1, which we said was 5. And then g of 5 is equal to 6. Okay, so I just want to write down how you would read that. G of f of 1. And we usually see it embedded like that. Another way you might see this notation is you might see g of f of 1. There's a little o there. It's not a dot because that would be multiplication, but it's read g of f of 1 just like g of f of 1 is read. So these mean the exact same thing. Okay, we're going to look at this for a different input. So what if x equals 2 is our first input? Okay, well, we're going to put 2 into the first function. I'm going to erase my marks on the table here. Okay, so if we put in 2 into the first function, that's here, the output is going to be 3. So then we're going to put 3, that output is going to become our input into the next function. And when we do that, the output is 8. So again, as a picture, we put 2 into the f function. The f function does its magic, okay, and comes out with a 3. And that 3 goes into the g function. The g function does its stuff and comes out with an 8. So using function notation, we can say f of 2 equals 3. And then the g function is saying g of 3 is equal to 8. Okay, so then we think about the composite. What did we do? We found g of f of something. So the first thing we did was we put in the 2. And we found f of 2, which is 3. And then we found g of 3, which is 8. Okay, so the notation would be g of f of 2 equals 8. So what I'd like you to do is pause the video and go through parts C and D on the next page. See if you can fill out the rest of the table using this idea of composition, and then write your answer for D, or type your answer for D. Then you're going to do the next page, which is you try it using tables, so other examples with different tables. And then when you come back from pausing, we're going to go through this example using function formulas instead of tables. Okay, hopefully you have done all of the stuff that I asked you to do before coming to this page. We're going to use these formulas now. So instead of having a table, we have to plug in values to figure out. So I'm going to do some more examples up here first before we get into any of the composite functions. So we're given that f of x is equal to 2x plus 1 and g of x is equal to x squared. So if I ask you for f of 3, hopefully you remember that this 3 goes into the x in our function. Okay, so the f function says takes a number, multiply by 2, and add 1. So we're going to take our number 3, multiply it by 2, and add 1 to get 7. I can even do f of star, because star is just a symbol, just like 3 is a symbol. And what that means is I can do 2 times star plus 1. I'm just plugging in my input into the variable. So whether that input is a symbol like a star, or a number, or a letter, or even another function, which we'll get into. So going through the same steps that we did when we had tables, when I put 1 in as an input to the first function, I'm going to put 1 in to my f function. When I do that, I get 2 times 1 plus 1, so 2 plus 1 is 3. So 3 is going to come out of that function. Now I'm going to take that output, which is a 3, and I'm going to put that into my g function. My g function tells me that whatever number goes in gets squared. So I'm doing 3 squared, and so the output is 9. Okay, so that's the composite function, where you're putting 1 in to one function, the output goes into the next function, and then you get another output. So using function notation, I can say that f of 1 equals 3. And, oops, now this is a second function, g of 3 equals 9. Then I can use composite function because I'm actually putting these all together, and I can say that I did g of something, and that something was f of 1. Right, so basically what that means is I did g of 3, because f of 1 equals 3, and all of that equals 9. So g of f of 1 equals 9. Okay, so first I take the 1, put it into my f function. That becomes the output of 3. And then I put 3 into the g function, and that output became 9. So if I use 2 as the input, if I put it into the first function, which is f of 2 is 2 times 2 plus 1, or 4 plus 1, which is 5. So that output now becomes the input for the next function. So my next function is g, and now I'm using 5 as the input for that. My g function is x squared, so this is going to be 5 squared. So my output is 25. Okay, so when I put 2 into f, I got 5, and 5 into g gives me 25. And again, using function notation, f of 2 equals 5. So when 2 is my input into the f function, I get 5. Now I'm going to do g of that same output, so g of 5 now becomes my input, gives me 25. Okay, and then on the last line, when we do this as a composition, we have g of f of 2. So remember, we've got f of 2 on the inside, and that's what becomes the 5. So now I have g of 5, and that's 25. Okay, now we want to know what a formula is for this composition. Okay, so remember when I have g of f of x. Okay, all this means is I want to take this function and put it into the g function. Now, my g function, g of something, is equal to something squared. Right? Well, what is that something? That something is f of x. I'm going to actually use a different color. So if f of x is my something, I'm going to put that into my g function. So I'm going to put 2x plus 1 into my g function, which means I'm going to square that. And that's how you write the function. So it's going to be 2x plus 1 squared. Now we can square that out if we want, but we're going to just leave it like that. Okay. All right, so you're going to pause the video and continue with the rest of this packet. And let us know if you have any questions.